Hello everyone, my name is Xiucheng Wu. In this video, I will introduce our project, RetouchIQ MLLM agents for instruction-based image retouching with Generalist reward. This project studies how to build a multimodal large language model agent for image retouching. Different from black box image generation, our agent performs executable editing actions through professional image editing software such as Retouching. The motivation is that many real-world editing requests are written in natural language. A user may ask for an image to look brighter, warmer, more cinematic, or more like an autumn scene. These requests are subjective and high-level, but the editing software requires concrete parameter changes. Our goal is to bridge this gap. The goal of RetouchIQ is to develop a specialized MLLM agent for image retouching with professional editing tools. The overall pipeline starts from a user request. The user provides an input image together with a natural language editing instruction, such as making the cherry blossom pop more. Given this request, the MLLM agent first reasons about what kind of visual changes are needed. For example, it may decide that the image should become brighter, the blossoms should be more vivid, and the overall color should be better match the user's intent. Based on this reasoning, the agent then generates concrete editing steps. These are executable tool calls such as increasing exposure or adjusting color grading parameters. Finally, these editing steps are processed by Retouching. The software applies the predict parameter changes to the input image and produces the final retouched result. So, the key idea is to convert a high-level natural language request into concrete, executable editing operations in professional software. A key challenge in this project is reward design. In many reasoning tasks, reward can be defined by comparing the model output with the ground truth answer. For example, in a math problem, the final numerical answer can be checked directly. However, image retouching is different. Usually, there is no single correct edited image. If the instruction is to create a fall scene with autumn vibes, many different edits may be acceptable. One editor may make the image warmer, another may increase orange tones or adjust the lighting. At the same time, not every visually noticeable edit is good. An edit may oversaturate the image, destroy details, or fail to match the requested mood. Therefore, a simple rule-based reward or ground truth comparison is not enough. We need a reward signal that can judge whether this edited result actually satisfies the user's instruction. Our solution is to use a generalist reward model. The reward model takes the instruction, the input image, and the edited results as input. It first reasons about the quality of the results and then gives a scalar reward. For example, if the user asks for an underwater scene to become more mysterious, the reward model can judge whether the edit improves the intended atmosphere. It may consider contrast, shadows, light beams, and color changes, and explain why one result better matches the instruction than the other. This is useful because the reward model evaluates semantic alignment between the user request and the edited image step by step. We then use the scalar reward to train the editing agent, so finally the agent can learn which two actions are more likely to produce instruction-consistent retouching results. We next show qualitative examples. The instruction asks for a wedding photo to look brighter with softer lighting and richer colors, while making the bride stand out with enhanced details. The input image is shown on the left. A good retouching result should satisfy the instruction while preserving a natural appearance. For this example, the edit should improve brightness and color richness, but avoid unrealistic colors or redundant enhancement. Baseline results show some unrealistic artifacts and some suboptimal editing results. For more results comparison, please take a look at our poster and paper. To conclude, we introduced RetouchIQ, an instruction-based MLLM agent for executable image editing. RetouchIQ translates natural language editing requests into parameterized editing steps for professional image editing software. To train the agent, We use a Generalist reward model that reasons about the edited results and provides scalar feedback, instead of relying on a fixed ground truth image. This framework improves instruction consistency and provides a transparent way to perform image retouching through real editing tools. Thank you for watching.